Hi, my name is Raphael Memmesheimer and today I present our work Fusion-GCN, a multimodal action recognition approach using Graph Convolutional Neural Networks. I'm with the Active Vision Group of the University of Koblenz-Landau. We tackle the problem of action recognition, and the action in our case is a label for a sequence of movements. In contrast to some other work, this comprises also gestures, interactions and group activities. Action recognition then is the classification of actions from time sequential data. Here we give examples like a waving action from the UTD-MHAD dataset and a carrying heavy as well as a transferring object action from the MMACT dataset. Action recognition is especially interesting because of the wide range of applicability, like for instance security and surveillance, healthcare, video indexing, or the improving of human-robot interaction. We propose an approach for the incorporation of additional sensor modalities into an already existing skeleton graph. For that we rely on visual modalities like RGB sequences, which we transform to skeleton sequences. The benefit of RGB is that we can also incorporate additional object information or environment information, and the transformation from the RGB sequences to the skeleton sequences narrows down to the movement of the persons in these sequences. When dealing with visual modalities, we usually have the downside of occlusion, brightness, reflections, and different viewpoints, as usual with camera sensors. We try to overcome this issue by the incorporation of additional modalities, like from wearable sensors, like for instance inertial measurement units or accelerometers from a smartwatch or a phone. Those come at the benefit with being invariant to disadvantages of the visual modality and have the cost of noise and usually lower usability. Here we give examples. We transform the RGB sequence into a skeleton sequence by using OpenPose, and we incorporate additional modalities like for instance inertial measurement units. Our objective is now motivated by the success of Graph Convolutional Neural Networks that usually build state-of-the-art results on action recognition approaches, especially when dealing with skeleton-based action recognition. And our objective now is to incorporate additional modalities and fuse additional modalities into the skeleton graph, which has not been done previously to the best of our knowledge. Our basis builds a GCN model as a base model, and we incorporate the additional modalities on two different levels in an early fusion scheme. So what does early fusion mean? We fuse our additional modalities on a representation level in contrast to late fusion schemes that usually fuse on a feature level, and late fusion comes at the cost of having one model per modality, and that increases the complexity by a huge margin, usually in contrast to an early fusion approach, which introduces a lower amount of additional parameters to one single model. So we propose to fuse additional modalities on two dimensionality levels, namely the spatial and the channel dimension. By spatial we mean that additional node attributes, nodes are incorporated into an already existing skeleton graph by introducing new nodes. For instance, here we show how to incorporate additional nodes for the accelerometer measurement and the gyroscope measurement on a central node. We can also incorporate additional nodes depending on their semantic relevance to the nodes that they are actually attached. So for instance, when dealing with a smartwatch, we can attach nodes on the corresponding hand. We also propose to fuse additional modalities on channel dimension. That means that we introduce additional node attributes onto the nodes like shown here. Our approach in general builds on the basis of a skeleton graph, and we can flexibly and incorporate additional modalities, like for instance features from RGB sequences, by extracting features from patches around individual joints, or even one feature per image. We further, as already suggested, incorporate additional other nodes, other modalities by fusing them into an early fusion model scheme. We executed experiments on the UTD-MHAD dataset and the MMACT dataset. The UTD-MHAD dataset is considered to be a toy dataset for showing a wider range of fusion experiments, and the MMACT dataset, which we focus here in this presentation, by being a large-scale dataset with also a huge amount of additional modalities. Here we give the confusion matrix of our results on the MMACT dataset with fusion of skeleton sequences and additional smartwatch measurements, namely the accelerometer measurements. And our approach works quite well on most of the actions, but we are confused when dealing with very similar actions, like we have a hard time distinguishing between carrying heavy and carrying light. This comes by the nature of their similarity, and we face issues with sudden movements, for instance by the jumping and kicking action, and a low amount of overall movements is also a problem, for instance for the loitering action. When comparing with the state of the art on the MMACT dataset, we improve by a huge amount the accuracy and the F1 measure. The most improvement comes from relying on skeleton measurements as the basis, or the transformation of RGB images to skeletons. But however, we are improving on those results by the introduction of additional accelerometer measurements. For instance, we got the highest performance by the fusion of skeleton sequences and accelerometer measurements from a watch and a phone. We also found that the model gets more uncertain when incorporating too many modalities, and we found it to be an interesting alternative that has not too high complexity added to the model. In general, FusionGCN proposes to incorporate additional modalities on two dimensionalities, namely the spatial dimension and the channel dimension, and we improve results on the MMACT dataset by a huge margin. And if you're interested in our work, you can find the implementation on GitHub, and here we give some references. Thanks for your attention.